Hi guys, it's Ian here. So this is a question that Chris asked and a video that he requested where he wanted to be able to determine what the overlap was between the buffers of boreholes or watering holes that are next to each other. And he asked for a buffer of 1 kilometer. In this example I'm going to use a 500-meter buffer, but this is where we're going to get to. We've got our watering holes, we've put a buffer on the watering holes, and then we've got intersecting areas between those watering holes, and if we select those areas we can see that there is a percentage overlap between the two. So if we look at the original borehole, that should be 100. The percentage overlap between watering hole 1 and 2 with a buffer of 500 meters is 52%. Okay, and the same for this one, 86%. And then if we calculate the overlap for a borehole or a watering hole that has a number of different overlaps between buffers next door, we can see that we have 65. The overlap between all three of them is only 42%, etc. So that's pretty much where we're going to with this video. Yeah, follow on and let me know if you have any questions. Cheers. Okay, so this is that video. So what we've got here is we've got a number of boreholes, watering holes, I beg your pardon, and for each of these watering holes we've got a column. We've got two columns. We've got a name and then a column with perennial. Now watering holes that are perennial have got a value of 1. Watering holes that are not perennial have got a value of 0. So the first thing we're going to do is we're going to exclude all of the watering holes that are non-perennial. So we can do that using the query builder. So let's close this down, open up the watering hole, water hole properties, and then if we go to source and open the query builder, we're going to add an expression to the expression window down here that will color up the boreholes we want to see or the watering holes we want to see and exclude those that are not relevant. So if we go perennial, so we're adding perennial to the expression window, equal to, and then if we just click on all, it'll display all the values. There's only 2 values for this column, so we want to say perennial equals 1, and then we say OK and OK again, and what will happen is it'll exclude all of the non-perennial watering holes. Okay, so we can now run a buffer on these watering holes. So we can select the vector menu, geoprocessing tools, and buffer. And then just make sure that your layer that you're looking to buffer has a projection in meters, and if it doesn't, it might have should have a little orange warning sign here indicating that your layer is in decimal degrees. But this is meters, so that is fine. And I know you were looking to buffer with a kilometer buffer, but in this example, I'm just going to use 500 because it works for this particular query. Okay, so with that set, we can create a temporary layer and click run. And it shouldn't take too long. Actually, that's happened pretty quickly, so we can close this down, and that is pretty much what our buffers look like. Okay, so what we can do is we can see that there is an overlap between these two boreholes, for instance, but we need to calculate the percentage overlap. So we need to somehow create a third area where these two polygons overlap. And then what we'll do is we'll use the total area and the intersecting area and calculate the percentage of overlap. So what we'll do to start with is just calculate the area for each of these buffered areas. So let's open up that attribute table. We're going to create a new column. And so I've started an editing session. The new column can be total area, and it is a decimal number, which is fine. And then what we'll do is just say $area, and that'll give us the area in meters squared, but we want to convert that to hectares, so we can say divided by 10,000, and that'll give us hectares. And here's our output value, which is what we expect to see. So we can click OK, and there we go. So now we've got the total area for each of those buffers. So we can toggle editing to stop editing and save our edits. Right, so with that done, we can now try create an intersection where we have a portion of the overlap as its own area or its own feature. And we can do that using a tool called the Polygon self-intersection. And that tool can be found in the toolbox. So we're going to open that toolbox, and just type in intersection up here. I've already got it typed in, and then we're going to look for a tool which is called Polygon Self-Intersection, and it's a Saga tool. So we can select Polygon Self-Intersection and then use the polygons for buffered. And we're also going to create a temporary file in this example, so just click Run. And that might take a little longer than the buffer, but it's still pretty quick. And close. Okay, perfect. So now that is what we expect to see. What we've now got is an intersection between the overlapping areas. So we can calculate the area for this, and then calculate the percentage, because we've already got the total area for each of these buffers. So let's open up the attribute table for intersection and do that. Okay, and this is what we've got. We've got a new ID field and a whole lot of new features, and each of those new features doesn't have a value for a name, and it also doesn't have an area yet, but these areas will all be the same. So if we start editing, the original area for each of these overlaps is going to be the same as the total area. So we can just say we're going to open up the calculator, we're going to update an existing field, we'll update total area, and just type in the value there, which is 77.251, and then OK, and that'll just give us the total area for all of them. And then what we'll do is create a new area column for each of the new features. So we can use the calculator again, and we're going to call this one, let's just call this one area. So the one's total area, and this one will be area. It is also a decimal number, and we can just say $area divided by 10,000 to get to hectares again, and then OK. There we go. Okay, so now we have two areas. We can calculate the percentage of overlap. So let's do that using the calculator again. So let's open up that calculator. We'll create a new column. Percentage perc over. Okay, that makes sense to me. Maybe I should put a little underscore in there. Percentage overlap. And it'll also be a decimal number, and we can maybe change the precision down to 1. Okay, so what do we need to do? We need to take the area, so inside inverted commas, I'm going to go and select and add the column area, divided by the total area, and then times that by 100 to get it to a percentage. So there we go, there's our output preview. That equation looks right, so let's click OK. And there we go, so now we've got a percentage column for each of the overlaps. So if we drag this to the side, and which one? Let's select a couple of these different areas. You can actually see, where's this one? Okay, let's try this overlap. Okay, so this overlap between these two buffered, so that the buffers for each of these watering holes has got an overlap of 52%. Okay, so that makes sense to us. So now we can see that so overlaps have a percentage, and that's going to work for us. So now that's where there's just two polygon overlaps. What about where there's a larger overlap? So for instance here we've got a portion of the polygon of the area that is actually belongs to 3 of the original buffers, and if we just want to see how much of this watering hole 8 overlaps with other areas, we can select all the areas, and then if we just have a quick look at the attribute table, we can see that it is included percentages of 42, 17, and 56, and you can just do a quick head calculation and calculate that, or you can also use the summarize tool, and that'll open up the statistics window docked on the right hand side of your screen. And we want to see what the total overlap area is as a percentage for these three features. So we need to make sure that we choose the selection layer, the intersection layer, choose the percentage column, okay, and then just make sure you choose selected features only, and then the sum of selected features only is 65. And what about this one here? So we chose that one. That sum would be a 72% overlap. If we deselect that one, we can see that that sum is at 83% overlap. How about these two? 86, and I think this one, what did we say it was, like 52 or something. There we go, 52. So that's how you can quickly do a query and see what the percentage overlaps between your watering holes or boreholes is. So I hope that's been useful. Give me a shout if you have any questions. Cheers. Oh, okay, I almost forgot. Chris, you also asked me about topology and looking to identify overlaps using topology. So we need to turn on a tool which is called the Topology Checker. So we'll go to our plugins, manage and install plugins options. So select that. And then it should be an installed plugin. There we go. So if you can't see it, just type in topology and this option will pop up. So we're going to select Topology Checker and then close. And that'll give us a new option under the vector menu. So what we'll do is we'll check the overlaps for these two buffered polygons. So you can do overlaps between two separate layers, or you can check overlaps within a layer. So we're going to check overlaps within a layer. Let's just change this color slightly. I'm going to make it, what should I make it? Like a lighter blue. Let's go with something like that. Okay. So now what we can do is we can go to Vector, Topology Checker, and then this is where we need to create a rule for the topology we're going to check. So we click on the little spanner to create a new rule, and we want to use a layer. We're going to use the buffered layer, and then this is where we set the rules out. So we've got one here. So that one has been added from previously, but if you open this for the first time, this is what you'd see. So select your layer and then create the rule, must not overlap, and then you need to click on plus or add rule, and there we go. So we can say OK, and now you just need to make sure that you check the error. So if we click on this little validate all button, that'll validate the errors. So let's validate, and then every area where there is an overlap will be highlighted in red. Okay, so that's pretty much how you use the topology checker to identify overlaps. And there are a number of other rules that you can go through and explore in the topology checker, and then just, I think the best option is just to explore them and then see how they work and see where you might use them. Okay, so this is the end of the video now. I'll chat to you again soon. Cheers.